Welcome to Applied Animal Feeding. In this series, we're going to be covering a variety of topics related to the application and real-world feeding scenarios for mostly livestock, but we may talk about a few companion animal species as well. In today's video, we're going to be talking about understanding dry matter, what dry matter is, and why it's so important. For this video, you're going to be prehending information to take in, just like an animal prehends food, the following objectives. First off, we're going to define dry matter and as fed and what that means. We're going to identify the relationships between dry matter and as fed, and specifically with the expression of feed weights or nutrient concentrations. We're also going to determine and apply appropriate solutions to convert from dry matter to as fed or as fed to dry matter. When we think about dry matter, the most common species that this is so important in is generally animals eating high moisture feeds. Most commonly, that's going to be our roughages and the herbivores like horses, cattle, sheep, etc. So we could have like these dairy cows eating a total mixed ration, or what we call a TMR. That could be 50 to 60% dry matter. And so there's 40 to 50% water in that feed. Those lambs grazing that fresh pasture, that could be as low as 20% dry matter or 80% water. A good corn silage that's put up well is 30 to 35% dry matter or 65 to 70% water. Hay is preserved by drying it, so it's actually very low moisture. It runs about 88 to 90% dry matter. So all of these feeds vary, and that water in those feeds can act as a diluent to our nutrient concentrations. So we, as nutritionists, have to be able to account for water. For example, if we take that bale of hay, we've got our water, carbs, proteins, fats, vitamins, and minerals. All the nutrient classes are in that bale of hay, just at different proportions. As a nutritionist, if we mathematically remove that water, we're taking away that dilution factor, and now we know actual amounts of carbohydrates, fats, proteins, vitamins, and minerals located in that dry matter. And that's what we balance rations on, because the water content of our feeds can vary so much. If we take that 100 pounds of silage that has a lot more water in it and remove that water, you realize it probably had a bigger dilution effect on those nutrients, and we're left with a smaller proportion of dry matter that's going to contain all of our other nutrients for that silage. So up next, we are going to learn how we mathematically convert between dry matter and as-fed bases for both weights and concentrations of nutrients. To show how the math works for this dry matter concept, I am going to use a notepad, just like I would a dry erase board if we were sitting in the classroom. And so a couple key concepts to remember is that we're going to be looking at feeds. And a feed is merely a vessel for us, a way to get nutrients for our animals. And now all of our feeds are going to contain different amounts of nutrients depending on what they are, what their category is, all of that. And so our job as a nutritionist is to blend feeds in such a way that we're going to meet the requirements for a given class of animal, whatever class of animal that might be. It could be a beef cattle, a lactating sow, whatever the case is. The other thing we need to keep in mind is that the most variable nutrient is water. And so while water is extremely important, as nutritionists, we don't necessarily balance rations based upon the water content because we know most of our producers are going to be providing fresh, clean water to our animals at all times. And so where this becomes really important is in high moisture diets. Things like what herbivores eat, whether ruminant or non-ruminant, all the roughages can have high moisture contents. If you're feeding dogs and cats fresh foods like meats and stuff like that, that raw food diets, that can have a lot of moisture in it. And making sure we're accounting for that is important. So let's start with our definitions. Dry matter. You'll see it abbreviated as DM. In the literature and everywhere, that's a standard abbreviation for a dry matter basis. And that is a component of the feed that is left once water is removed. And this component contains all other nutrients. And so that is the dry matter. Now, the second major way we can look at this is as fed, which I do abbreviate as AF in my notes here, just so you know. It's not what you think it is. And that is how the feed is presented to the animal as fed. Okay, we're not accounting for the dry component. We're not accounting for anything else. It's how the feed is presented to the animal. And so these two terms are ways, or what we call, can be considered a basis, or a way that we express nutrient concentrations, weights. And so sometimes we have to be able to convert from a dry matter to an as-fed basis, or vice versa. And that's what we're going to be working on today. So I'm going to go back to kind of like that image we had in the video on the PowerPoint slide, is that we know our feed has two components, two big components, the water and the dry matter. And all of our nutrients are in this dry matter. But if we remove this water element, we are left with just dry matter. And so this is the as-fed basis. This is the dry matter basis. And so to go along with that, I'm scooting this up a little bit. We're running out of visible room. So to go with this, we need to understand that nutrients can be expressed one of two ways, either by weight, and we're talking pounds, grams, kilograms, whatever weight, ounces can be expressed in ounces as well, or as a concentration. And so that's where we're talking about percentages, parts per million, calories per pound. those are all considered concentrations. So we need to understand how these two bases impact both weights and concentrations. Let's take a look. So if you haven't figured out yet, I like to use this diagram just to kind of remind us, like visualize a bag of feed, a bale of hay, whatever the case may be. We know we have water and dry matter. So if that water gets removed, we are left with, let me try to make it at least look somewhat similar, dry matter. So we have our as-fed form on the left, and we have our dry matter form on the right. And so when we're dealing with weights, we're going to put the two ways that nutrients are expressed here on the side, weight or concentration. With the water added from a weight perspective, as fed is always the heavier of the two. Dry matter is lighter. Okay, because that water is going to be adding weight, so it will be heavier. From a concentration basis, it is going to be a nutrient like protein or fiber or something like that is going to be less concentrated because water acts as a diluent. And so it's going to be diluted. Dry matter basis is going to be a higher concentration because there is no water to dilute that. So one of the things that I always have students as a check to make sure you're going the correct direction is ask yourself, do you need a bigger or smaller number? And so if we're thinking about the weight basis, the as fed is going to be the bigger number. Keep that in mind. On a concentration basis, this is less concentrated, so a smaller number. So over here, the dry matter basis is going to be the bigger number. So that's just always a good checkpoint. Do I need a bigger or smaller number? All right, as we move into the converting between these two, here are some tips that we need to consider as we're doing this. One, it is all about relationships, mathematical relationships relating to the two. So we can handle this mathematically. And just keep in mind that water dilutes, it's supposed to be an S, concentrations, but adds weight. Okay, so always keep that in mind. Water dilutes, but adds weight. So let's put this into practice a little bit. We're going to start with concentrations of nutrients. And so you're going to first, and let's kind of break it down into some steps so that you can kind of process through how to solve these and how to not just solve them to get an answer, but to make sure you're converting in the right directions. So step one is to ask yourself, are you going from as fed to dry matter or dry matter to as fed? We have to identify what kind of problem we have, which way we're going. The second thing is you need to look up the dry matter percentage of that feed. Okay, And this can come from a lot of different resources. If you're in a class taking this and using this video, ask your instructor what resource you're using. There are quite a few out there. The Noble Foundation out of Oklahoma has a feed library that is free to use and online, works extremely well. Many of us have textbooks that have feed tables in there, that it could be a source. If you're in one of my classes, I have developed here at Chico State a searchable spreadsheet, because I've had online resources crash at a couple key moments. And so there's a variety of ways that you can find this data. Another online source is Feedopedia, like Wikipedia, but for feeds. They have a lot of composition data on that website as well. So somewhere, somehow, you're going to find the dry matter percentage of the feed that you're working with. The third step is to look at the relationships using this equation. Okay, so when we're solving for nutrient concentrations and converting between dry matter and as fed, we're going to set it up like my diagram earlier. We're going to have an as fed side, and we're going to have a dry matter side. And the relationship between the two is equal. There's the same relationship mathematically. So we're going to take our nutrient concentration on an as-fed basis divided by the dry matter percentage on an as-fed basis. So when you look up this dry matter number and it says 75, that means that 75% of that feed is dry matter on an as-fed basis as it's presented to the animal. This relationship is going to match the relationship of the nutrient concentration on a dry matter basis out of 100% dry matter. So this is fully dry. This is the full dry matter basis on this side of the equation. And so let's take a look at a problem to help us understand how this works. We have a cow that's grazing sagebrush. Okay, and we know that that fresh sagebrush is 6.75% crude protein as fed, or how it's presented to the animal. We want to know, our question is, what is the percent crude protein on a dry matter basis? That is our question. So, first step, which way are we going? We know the data as fed. Our question is, what is the dry matter? So we're going as fed to dry matter. So water acts as a diluent. So if we're removing the water, we should be removing the dilution, and the dry matter should be a bigger number. Just so we kind of know where we're going with this. And I looked up using my resources here, I've looked up the dry matter percentage, and sagebrush is 50% dry matter. And again, that would be on that as-fed basis. Okay, so now we know that we're going this direction. We have to have, the goal is that we always have to have 3 legs of this equation. So now we know the nutrient concentration as fed, the dry matter percent, and we know the 100% dry matter basis. So now we can plug in numbers. So let's start with 6.75% crude protein over 50% dry matter on an as-fed basis, and that is going to be equal to X. What we don't know is this nutrient concentration on the dry matter basis, but we do know that this is 100% dry matter. So we have 3 legs of the problem. That's all we need. And just so you know, when you're doing this, you will always be able to get this information. X is either going to move from this side to the other or back. X will only be on the numerator side of this. Then we cross multiply. So we wind up with 50x equals 675. Okay, so now we, basic mathematics, we isolate x. So now we can divide 50 by both sides, and x is going to equal 13.5% crude protein on a dry matter basis. And if we go back to our initial thought, as fed to dry matter, we're removing dilution. We should have a bigger number. Is this number bigger than what we started with? Yes, it is. So that's how you'd go from as fed to dry matter. Now let's look at an example that's got some differences to it. Okay, so say we're going to do another example, and say we have some steam rolled barley. I am abbreviating it just because it's a little easier to write. And we know that it contains 0.61 megacalories per pound of, actually this is megacalories of NEM per pound of dry matter. So this is a concentration. Calories per pound is a concentration that if we know how many pounds, we can figure out what how many calories they're getting. So our question is, how much NEM per pound on an as-fed basis? Okay, so if we go back to our first question previously, we are going from dry matter to as-fed. So we're adding water back in, we should get a smaller number. Okay, that makes sense. Second step is to look up steam-rolled barley and find its dry matter percent. And I looked it up in my searchable spreadsheet, and it is 86% dry matter. Okay, now we need to set up our equation, because now we should know the 3 legs of it. Now, one thing that you notice, this is out of 1 pound, not 100%, not a percentage basis. Oh, that kind of skipped out of the screen a little bit. Okay, so that does change how we set this up a little bit. We still will have our as-fed side and our dry matter side. And in this case, we know that in 1 pound of dry matter, we have, or 1 pound of dry matter, let me get that on this side, we have 0.61 megacalories of NEM. And then we know that in 1 pound of dry matter, if we took 1 pound and times 86% or put this on a decimal form, that would be 0.86. Okay, because the decimal form is the same as taking 86 divided by 100. That's where we get the decimal form. This is a side quest there. What we don't know is how many calories on an as-fed basis. So again, we have 3 legs of the equation. We can solve for x. I kind of like these megacalorie ones. So we're going to cross multiply. So we get 1x equals 0.52. I rounded to to 2 decimal places, megacalories of NEM per pound. We could divide both sides by 1. That's going to give us x equals 0.52. But that way we know that we've got per pound as fed. So if we want to check that we're going dry matter to as fed, we should get a smaller number. Is this number slightly smaller than the one we started with? Yes, it is. And so the only reason this has a 1 pound on the bottom, the denominator, is because energy, like digestible energy, metabolizable energy, net energy, can be expressed per pound. And if that's the case, move the decimal. All right, so that is 2 different ways to go from dry matter to as fed to dry matter on a concentration basis. The other basis that we talked about is weight. Okay, and so when we're dealing with pounds of feed, so we're going to follow the same steps. We're going to first determine direction. Are we going as fed to dry matter or dry matter to as fed? Which way are we going? Second, we need to look up the dry matter percent. And third is salt, which is essentially what we were doing the last time. So now these are a little bit more straightforward. You don't have to cross multiply, and there's no X involved in these. And so let's say we have a TMR, which remember is a total mixed ration that requires 500 pounds of corn as fed. So that's how it would be put into the mixer to go into the ration. But our nutritionist wants to know how many pounds of dry matter is that. Okay, so basically we're taking, and sometimes I draw this out to help visualize it. I'm a visual person, so ways that to help me explain something is we have 500 pounds of corn. We know some part of it is water. And so what we're trying to solve is how many pounds of dry matter is there. So we need to, so we've established one. We're going from as fed to dry matter. We're removing the water, aren't we? So we should be reducing the weight. So we should need a smaller number because we're taking out weight if we remove this water. We're going to look up the dry matter percent, and 500 pounds of corn is about 88% dry matter. So this is to solve this, we always multiply to get a smaller number. So we're going to take our 500 pounds corn as fed times 0.88, the decimal form of 88%. And that is going to give us 440 pounds of dry matter. So we started with 500 pounds of corn as fed, removed the water, and wound up with 440 pounds of dry matter. We did get our smaller number. Let's take this the other direction. Get my examples out here again. So now we have a goat that is eating 5 pounds of haylage, dry matter per day. So that goat is getting 5 pounds of its dry matter from a haylage product. And so we want to know how much do we need to feed it. How much needs to be fed as fed to achieve that. So now we're going from dry matter to as fed. We're adding water back in, so we should need a bigger number. If we look up, say like a brome grass haylage or something like that, we'll find out that it's about, it's about 35% dry matter. Haylages and silages can be very, very high moisture. And so in the previous problem, we multiplied to get the smaller number. In this one, we're going to divide to get a larger number. So we're going to take that 5 pounds of dry matter and divide by 0.35. And so what we should find is that we get 14.29 pounds as fed. So that goat needs over 14 pounds of that haylage just to get its 5 pounds of dry matter, which makes sense if we take a look visually and we realize that this feed is only about a third dry matter and the rest of it is water. So we're going to have a big swing on high moisture feeds. Our numbers are going to swing quite dramatically. So that's how we solve for these different, to convert between the different bases. So as we wrap up this video, what you're going to be ruminating on or chewing upon, or what you should have learned from this video, is about the relationships between dry matter and as fed and how those are expressed, that water dilutes nutrient concentrations and adds weight to feeds, and always check and ask yourself, do I need a bigger or smaller number? Which direction am I going? That allows you to check your work fairly efficiently. Stay tuned for the next video of the Applied Animal Feeding series.